Okay, I accidentally just pushed go live. So we should be live. Let me actually check on my Twitter because I have been bamboozled before. Um, no, it looks like it's working. Okay. So, what were we just talking about? Well, maybe we should give like a recap to how far we are or give some context.
Yeah, go ahead.
So basically, last time I tried streaming this, Nashqueue joined, and then the stream kept crashing because of Google Meet. So we're trying it a different way today with Restream Studio, and we in that time where the stream crashed, like afterwards, we just continued going and got to the point where, at least in theory, we have constructed all quadrants and created and in that process created the tree that we use as a source of randomness to do the rest of the encodings with. So there are no tests, so it's very unlikely that it actually works at this point. But we do have like this base implementation that we think would work in theory. And today, I guess I wanted to go a bit further and either clean things up or add the next types of trees that we're gonna need. Like we can maybe go on Excalibur and talk about what we talked about with the trees, like make a visualization first.
Yeah.
Because it doesn't really show up here.
Sure. Like I can just ask the question that I wanted to ask just before we went live.
Yeah.
The X commitment is over X, like it's over Q1 and Q2. But if you go to the bottom tree, well, yeah, the one, not the complete bottom.
Maybe we should read element of Q. All right.
No, yeah, right. This one, yeah, the element OP QRS.
Oh yeah, because this is Q1 and Q3, right?
This is Q1 and Q3, yeah.
Okay.
And we are creating a tree like this, right? Are we over the rows?
Should we check? Yeah, because this is the problem we had, is that we were like, oh, do we need to hash every single element? And then we determined, yes, we do. So I can look in the code real quick. Create tree, transposes, rows extend, flattens. Yeah. We take the hash of every single, so the hash of this, hash of this.
Yeah.
For every single thing. But this is what it looks like internally, right? In the deck.
Yeah. So we create a tree we create basically a commitment over the two quadrants.
Can you explain why we need why this tree is not sufficient? Why do we need more trees? Did you get kicked out of the stream? Okay, so this solution is also not perfect because his phone can't handle it and he can't join from his computer because he uses Linux, so his audio drivers are scuffed. So he's going to have to like keep rejoining. Hold on, now I can reactivate him. Hello.
Are we gonna have to do this like every 5 minutes?
Like apparently.
That's crazy.
I don't see a better solution. Once we're done streaming, though, we can just go to Google Meet.
So we should do the same thing with the Y commitment now.
Which is just the right side?
No, yeah, it's a top side. So it's Q1 and Q2.
Oh, so the question I asked right before you left was, can you explain why we need more, like, why is this tree not sufficient? Why do we need more trees?
So when we are doing the verification, what the light client gets is the commitment of X, the commitment of Y, and possibly the commitment of Z. We haven't really talked about Z yet. And you need to prove the rows in Q1, Q3 against the commitment of X. And you need to prove the columns in Y against the commitment of Y. And then doing what like ZODA does in the verification is multiplying a row against the column, like having a dot product, I think, and then you get the randomness out of it.
With the linear algebra as a PSYOP. It's just a formalization.
No, you actually do a.
Well, yeah, the dot product part
you
is
do
real,
a check,
right? Yeah, but so okay. First of all, we have.
This is Y.
So this is Y, yeah.
Yeah.
That's a terrible Y. That almost looks like an X. Y. Okay.
Yeah.
And then this is going to be helpful later, I'm sure. Okay. And then this is X, obviously.
Well, do you?
Oh, there he goes again. Fuck. This may not work out. King. Oh, wait. Well, you rejoined quickly that time. But now you have no audio. All right. So there's obviously 2 more commitments we have to make here. I should probably open my Telegram. See what he's saying. No, nothing. Just kids is why you should not use Linux. Don't fall for the nerd trap, or what is it called? Nerd snipe. Everyone outgrows their Linux phase. Audio keeps dying. Rejoin. Well, nothing. All right. So there's a few commitments we have to make here. X, Y. I don't know which direction these are supposed to be, but gonna remove him from the call and see if he rejoins. So we need these other commitments because eventually, like, the goal of this is that you're sampling against the structure. And so you need the permutations in order to be able to check against the rows and the columns that the encoding was done correctly. Particularly against X, I believe. So Nashqueue's gone. he's gonna try to restart his phone. His mic doesn't want to connect. Oops. It's so over. Okay, so I guess Nashqueue's gone. RIP Nashqueue. So we're gonna have to solo this for a little bit, at least. But I don't want to end the stream immediately because that would be a waste. We will end up working on it again. Maybe I can just walk through where we are, and such. So, basically, we're at the point where, what's up with this? That was wrong. I don't know what's up with this theme. Something weird happened to my ZODA that I can't explain. This is probably it. There, that's good enough. So, first of all, we're gonna have to write tests, but what we do is right now, like everything is done this extend method, so we assume that the data square already has data encoded as columns that are field elements. And then we first like read Solomon encode the original data. So the original columns are just Q1, right? So I could actually rename this to Q1 calls, I think, unless we set the calls later on. I don't think we do though. We do not. So it would make most sense to rename this to Q1 call. And then once we extend it, this is like the full column and full row representation of both. What's annoying here is that you can't have like one canonical representation and just do operations on that, because you introduce abstractions that would kill it anyways. Oh.
Yes.
Okay. You're back.
But for how long?
Yeah, I'm gonna try a little bit more. I was walking through the code.
Yeah, I was listening.
Show how far I am, and then like if it's really not working, we can just go offline and upload the recording from like, what is it called?
Meet?
Yeah, Gmeet, thanks. Brain is fried. So like here is where I have, okay, well, we need the row roots and column roots, right? I'm trying to think of.
Do you want to go back to the
Excalibur? Yeah, I wasn't
Yeah.
done with that, but I couldn't go further without you because you abandoned me.
Let's try it.
So
there's that, right? And what else gonna happen here is we're gonna have a third commitment, which is gonna be commitment of Z, which is gonna be over all Q1, Q2, Q3, and Q4.
Oh, I thought you had told me previously that there was 4 commitments.
No, there are 3.
Because I thought you'd need Q1, Q2, Q1, Q3, Q3, Q4, and Q2, Q4. Like one for each direction.
I don't think that's necessary.
No? Okay, let's think it through. So if we have,
because you only need yeah, go ahead.
Ultimately, you have to verify against X, right? like, because that's where the randomness,
Yeah.
where the entropy is generated.
Yeah.
So I don't understand how this setup works yet.
So
This is
y
not
is going to
explained
be
anywhere.
y is going to be part of z.
Right. Well, both are part of Z. Like these are just subtrees
No,
of this Z tree, no?
no, because like z and y are on a different plane where we already multiplied by the diagonal matrix.
Well, yeah. Well, Q2 is multiplied by the diagonal matrix, and Q3 is not.
Yeah, but like q1 in y is multiplied by the diagonal matrix.
Really?
Like look back into the tree that we drew.
For this?
Yeah. You see
Oh,
how on the left side we did the multiplication?
my brain has lost the context for why we need to do this. Oh,
So yeah, we first multiply by the diagonal matrix, and then we create the tree over it.
because this is technically already multiplied.
Yeah, Q1 is already multiplied.
Okay. Is your audio still there? It sounded kind
So
of
those
cut
are
out for a second. Yeah, okay. It is.
so they're like two different.
Oh, there he goes again. All right. So beautiful. He gives up. So RIP Nashqueue. I'm just gonna go through it and then have to stop the stream again, I guess. I might do one or two things. I'm gonna write him. I'm letting you go, setting you free. We'll All right, so the stream was a failure. Now we know that we can't use this method, and also that Nashqueue needs to buy a MacBook. Or at least some laptop that works or fixes audio drivers. So, one area that I have here is that we are no longer, like, I cleaned things up in the extend because before it was a huge method. But then I created this from calls that takes each quadrant as columns and then creates the extended data square. And this has the diagonal matrix and the columns and rows, but it does not have the tree yet. And I think we should probably add that. So let's say like X tree would be, is that the type? We have a Merkle tree SHA-256 algorithm. It's a weird import. But I think this should also be fine. So we have X tree, Y tree, Z tree. So X is over the, oh, I'm showing you Scala draw. I've done that so often. Okay. So we need the X tree, the Y tree, and the Z tree. And this is over what? This is over, I think the column-wise column-wise representation of over Q1, Q3, then over rows of the Q1, Q2, and then this is I'm not actually sure because Nashqueue just said it's over all quadrants. So I'm actually going to comment this out for now until Gabriel can help me there, or Nashqueue. So now we need to add this. Extrude the tree. Let's see if it's even the right type. No, because I'm not passing it. I think that should work. And then down here we can just say, so let extended data square is extended data square is Q1 calls clone, and then Q2 we only have the rows, so we have to transpose that, and then to transpose Q4 as well. Right? It definitely does not like that. Why? Because it's because these are results. Let's use question mark operator, and then we can say okay, yes. Still does not like this because Q3 calls is what is after moving there. We're gonna have to clone it for now. Or can commit an I don't know. I think it has to own it. I don't think we can really pass a reference there. There's gonna be a better pattern to do this, but I'll ignore that for now. And then once that's done, I just need to comment back out the Y tree, or we can consider how we're gonna make it. Like, so if it's over the rows, how are we doing it here? So if we have create tree, we probably need to rename this to create X tree, and then we're going to need a create Y tree. I think I'll put that right here. And what it's going to need are the Q1 rows and the Q2 rows. Wait a minute. I'm realizing that the X tree is transposing the columns 2 rows first, which we do not want, right? Like if we have, and I'm talking about the X commitment right now. This is the X commitment. Oh no, this is the column representation. And this is what I guess I was already doing. Nashqueue, are you still watching? So is it, so he's writing to me in the chat, by the way. Could you write in the public chat, possibly? There is the public chat also inside of this application from your computer, but because I wrote down both here, I don't know what the tree should actually be. Is it supposed to be LMNO or is it LNPR? Like what should I be putting into this X tree? LMNO. Okay, so I should be converting it to rows first. So, I don't think we need to like have multiple methods that do this because we just do this outside of the function. Like, so we'll just need to transpose from the outside. And then I would say we just pass in 2 quadrants here. It'd be stupid to name them Q1, Q2 because that obviously is loaded already. So I guess we could say matrix 1, which is vec felt, and matrix 2, vec felt. And then this is going to then not do this. But we can say I'm going to name this repr because it doesn't matter if it's columns or rows. Repr.extend by matrix 2. Once we do that, then we can just iterate flatten. That's fine. Now I'm wondering if we can just pass in a reference. We're only really, I'll worry about that later. Not important right now. So what I have to pass into here is going to be self.q1 calls dot clone. And then I'm going to have to transpose this. And then transpose this, because we need the rows. And then I'm going to name this X tree, of course. And we're going to need the Y tree as well, but I'm wondering if we should create it here or create, well, I guess we're extending here. Like this is the part where we make the extended data square. So we should be passing in. See, now my question is, should we be doing it from this extended data square from calls thing or not? And I think it makes sense to do it here because we're already making the X tree here. So we can say Y tree would be self.create tree, and that's going to be of what? Of Q1 and Q2, but of the column-wise representation. So we can actually just say self.q1 calls.clone, and then Q3 calls.clone. Y tree, and then this is X tree, and then I can uncomment this, and we can copy Y, blah, 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 Y tree, and then there we have both representations of the tree. It doesn't like this though. Typing rooms somehow. And I also need to make sure that doesn't result in an error. Perfect. Okay. That's great. I'm going to upload this before I sign off to go actually work with Nashqueue, which I will record. I'm putting the repo up here in case you want to go take a look. It's not much code yet. We're just playing around still. There's other code in there that eventually I need to rewrite RSNT, 2D, and REST for to get it working, so we can actually write pinch marks. Because like this is just blindly taking field elements, and we need a way to obviously convert bytes to these field elements. So that part will also be interesting and probably more fun to watch because this is pretty like theoretical and math heavy, and then the rewriting RSMT2D is mostly just like boilerplate and writing Go code in Rust, so it should be fine. Just do git commit am adding y tree. Perfect. Okay, then thanks for watching. If you did stop in, sorry it didn't end up working out. Gabriel or Nashqueue and I will figure out a way to actually stream together, so that this can actually be a thing. But yeah, all right. Thanks for tuning in. I will upload the rest hopefully. Okay, bye bye.